कि वो कैसे बनाना है. Obviously, through dehydration. Through dehydration. Dehydration means the removal of water molecule from like if you are going to add concentrated sulfuric acid, so ultimately your alcohol would be converting into alkene. So we did the paper till question 5. Inshallah, we would be like completing the paper. So this is question number 6. Compare and explain the relative acidities of butanoic acid, ethanol, and water. So what do you think? Which one is the most acidic one? What do you think? Which one is the most acidic one? Yes. Haji, which one is more acidic? Which one is less acidic? Yes. And also with a reason. When we were discussing this topic, it's related to also the ionic equilibria. Basically, a strong acid is the one whose anion is more stable. I'm repeating, a strong acid is the one whose anion is uh, more stable, and less acid is the one whose anion is less stable. So basically, it's all about the anion. So you have ethanol, that is, I can say C2H5OH. Then I have CH3, um, CH2CH2COOH, and then you have CH3COOH, and then you have water. Then you have water. So we have ethanol, then butanoic acid, then ethanoic acid, and then we have water molecule. Okay. Uh, yes, most acidic, and also I told you the nature of alkyl group is electron donating nature. The nature of R group. The nature of R group is electron donating nature basically, right? So what do you think? Uh, it has two alkyl groups, like it has two carbon atoms, it has three carbon atoms, it has one carbon atom, and this is simple H2O. So I think so. This should be the most acidic because this is carboxylic acid. As compared to alcohol, okay, as compared to alcohol, carboxylic acids are more acidic. Carboxylic acids are more acidic. If you ask why, I would say that its carboxylate anion is the more stable one. Its carboxylate anion is the more stable one. If you ask why, I would say due to delocalization. Let's suppose when you are going to dissociate it, it would be giving you this anion, that is this. And when you are going to dissociate this, it would be giving you this anion, okay? And when you are going to dissociate this, it would be giving you this negative ion. And if you are going to dissociate this, it would be giving you this anion. So among these four, I would say this is the most stable one. I would say this is the most stable one. Yes or no? Yes or no? And what do you think, if you have any idea that which one is the more acidic and which one is less acidic? Yes. हाँ भाई साहिल ताला. Hmm? Any idea? But fast. You need to tell me fast. जल्दी बताओ बेटा. You are silent. Why you are silent? Hmm? Can you hear me? Can you hear me?
Yes, sir.
So why you're silent, man? जुमर 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 क्या हाल है? साहिल क्या कहते हो यार? कोई आइडिया नहीं है? हम्म। एक तो बोल तो दिया करो यस और नो में यार।
Sir, but can you repeat the question?
सॉरी, व्हाट्स व्हाट?
Can you repeat the question? I didn't hear you.
You have the question. Can you see the question? Do you have my screen?
Yes.
So compare and explain the relative acidities. They are asking which one is the most acidic and which one is the least less acidic. What do you think? Then I would be telling you why this is so.
The most acidic is ethanoic, then
Ethanoic.
is
Okay.
butanoic,
Okay.
then water, then ethanol. The ethanol, butanoic water, then ethanol, since alcohol is the least acidic.
Okay. So I'm supposed to arrange in such a way that first of all this is, then secondly it would be this, third one, third one would be this, and the fourth one would be this. Let me explain this. Let me explain this. Let me explain this. K. Uh, okay. So, uh, it's more stable. It's more stable due to delocalization of electron. Due to delocalization. Okay. Or, and also you can say that, and also you can say that it's C double. It's It's basically this is the dissociation of alcohol, right? This is the dissociation of alcohol basically. Yes, now. So it's more stable. Why? Due to the delocalization of electron. Okay, due to the delocalization of electron. And also then I can say that its structure is this actually. Its structure is this OH bond. This is OH bond. This is OH bond. So I'm going to have a comparison between these two, ethanoic acid and propanoic acid. Ethanoic acid and propanoic acid, just like that. This is butanoic acid basically. So, this is electron donating group. This is electron donating group. Electron donating group. This is electron donating group. So strong acid is the one. Strong acid is the one which is going to dissociate its proton easily. Which is going to dissociate its proton easily. And if the acid is not going to dissociate its proton easily, I would say that's the weak acid. I would say that's the weak acid. So this bond is weak bond. This bond is weak bond. Okay, why this is weak bond? Why this is weak bond? Because it has a lone pair of electron and this lone pair is delocalized. This lone pair is delocalized into this. This is your carbonyl group. But here the CH3 is present, which is going to donate electron, which is going to donate electron basically. So it would create repulsion. It would create repulsion basically. It would create repulsion. So due to this, it's going to make this bond weak. That's why the OH bond is going to break down So ultimately, I can say that it can dissociate its proton easily. So that's why this is strong acid. What about this? This is your alkyl group with more carbon atoms. With more carbon atoms. Remember, if there are more carbon atoms, if there are more carbon atoms, so remember, it's going to have the electron donating effect that is just like that, okay, which is going to, when it's going to donate electron, it's going to create a strong repulsion. It's going to create a strong repulsion, a strong repulsion. As a result of this, its anion would become less stable. This anion is the least stable one. This anion is the least stable one. Remember. So as a result of this, when it's less stable, so again it would be reacting with the proton and would be converting back into the butanoic acid. So that's the reason I am saying that this is a weak acid. That's the reason. But if you are going to have a comparison between this and this, so it's more stable compared to this. It has the less number of carbon atoms, means the repulsion is lesser. Repulsion is lesser basically. When the repulsion is lesser, so it's more stable. It's the more stable one. So it tends to stay in the same form. That's why I can say it's a strong acid. But if you talk about this, its anion is the least stable one because there is no delocalization in this. There is no delocalization in this, okay? There is no delocalization in this. So, and सोने पे सुहागा ये है कि behind this you have the alkyl group which is going to donate its electron and which is making a strong repulsion between this electron and the already have a negative charge. That's the reason it's the least stable one. Least stable one. So again, it would be reacting with H positive ion and converting back into ethanol. So if you have this, this is OH minus. So it's more stable than this. You know why? You know why? It's more stable. It's more stable than this. It's more stable than this. Okay, it's more stable than this. But why? Because there is no any alkyl group between there is no any alkyl group. There is no any alkyl group before this OH that is not creating any type of repulsion. But if you can see this anion, it has a strong repulsion between this electron donating group and this negative charge, which makes this anion less stable. That's the reason this acid is the weakest acid among these all four. So it's of 4 marks. So you have to write in your own wording, okay? So basically, it is depending upon the stability of electron donating group. You can include sometimes like it has a strong electron donating group and it is more repulsive. So you can write in the whole pair. You can write in the whole pair. Okay. So basically, it is depending upon the stability of an anion. It is depending upon the stability of an anion. When the anion is the least stable, so means that your acid would be weaker, and when your anion is the more stable one, so your acid would be stronger. So your acid would be stronger. Okay. Now you can see this. Three carboxylic acids, methanoic acid, ethanedioic acid, and butane dioic acid are compared. Two tests were carried out on separate samples of each organic acid as shown. So it's going to react with test 1 is positive, negative, negative. Test is positive, positive, negative. So if the test is positive, what would you observe? And basically, which test am I supposed to do which test am I supposed to do if I'm going to have a comparison between like among these three? You can say okay, this is HC double bond OH and this is OH and C double bond O. C double bond OOH, and this is your C double bond OOH, then this is your CH2, CH2, C double bond OOH. You can see, you can see this is your, you can see that this is your aldehyde. You can see this is your aldehyde. This is your aldehyde. So it can give you a positive test for a Tollens reagent. I am going to add Tollens reagent. I am going to add Tollens reagent, or you can add Felling solution, or you can add, Felling solution. So first of all, you can add Tollens reagent, Tollens reagent, or you can add Fellings, Fellings solution, Felling solution. So, so what I would observe, if you have added Tollens reagent, I would observe silver mirror. I would observe silver mirror. And if you have added Felling solution, I would observe the red PPT, the red PPT. And you know, Tollens reagent is not going to react with this because this is not an aldehyde. Also, it's not going to react with this. Again, I can say this is not an aldehyde basically. And and if you can see, what test should I do for these three, which is going to be positive for the both ones and which is going to be negative for this? Um, you know, which test am I supposed to do? Yes, both are. This is carboxylic acid. This is also carboxylic acid. This is also the carboxylic acid. Yes. Hmm. Yes.
So KMNO4 oxidation.
Why?
नहीं सर, इसकी तो नहीं हो सकती.
Acidified KMNO4 you are saying, right? तो वो किससे रिएक्शन करेगा और किससे नहीं करेगा?
सर वो किसी से भी नहीं करेगा, वो इसमें 2 टिक लगे हुए हैं. आई डिडंट सी दैट.
देखो, basically if you can see, okay, your first one is HC double bond O or OH. Your first one is HC double bond O or OH. So this is the simplest carboxylic acid. If you remember in your alkene when you were oxidizing alkene, so I told you different cases. I told you different cases. So in that case, if you remember, when you were oxidizing this alkene with the hot KMNO4, so it would be giving you first this, okay, and then it would be giving you carbon dioxide and water. Means that if you have this one carboxylic acid, it can be oxidized into CO2 and water. It can be oxidized into CO2 and water. That's the reason it's going to give you the positive test. So yes, I can say that I'm going to add AMNO4 minus slash H plus, and I'm going to provide heat. I'm going to provide heat. So this molecule gonna give us the positive test for this KMNO4 and also this carboxylic acid, because this is also the simpler one, but this is not the simple carboxylic acid in which you can see the two carbon atoms. So this is the reason, if you are going to add KMNO4 and you are going to provide heat and also acidify the reagent, so you will see that KMNO4 will decolorize. If the KMNO4 decolorizes, so ultimately I can say that this molecule and this molecule is confirmed. Okay, so in both cases it's going to give you the positive test, right? Complete the table with the reagents and conditions and observe change for a positive test. Assume these organic acids all have a similar acidic strength. Okay, so we did this question. So part two is saying each compound like methanoic acid, then ethane dioic acid, and you have butane dioic acid is dissolved separately in CdCl3, its proton NMR. So proton NMR and carbon 13 NMR spectra are then obtained. So number of peaks in proton NMR, number of peaks in proton NMR. So proton means we are going to consider number of hydrogens. So it's the simplest carboxylic acid. I can see the two protons. I can see the two protons. So I will say that the number of peaks would be 2. And in the carbon 13 NMR, there is only one carbon atom. So I can say you will see only one peak. You will see only one peak. Remember, and in this this is dicarboxylic acid, this is ethane dicarboxylic acid. So this is the structure for ethane dioic acid. So the number of peaks in that spectrum is 1. If you are thinking why, because they are the same, this is symmetrical, this is symmetrical, 100% symmetry. 100% symmetry. So this hydrogen is equal to this hydrogen. So that's why you can see only one peak in that. You can see only one peak. And if you are going to do the carbon 13 NMR, so again you will see only one peak in this. Again you will see one peak in this, because again I would say that this is the symmetrical molecule. This is the symmetrical compound. And if you have butane dioic acid, that is this OHC double bond O, then CH2, then CH2, then C double bond OO and OH. So again, you can see the symmetry. This and this are same. This and this are same. So you will see two hydrogen, two peaks, two peaks. One peak for this, one peak for this, and another peak for this. This is symmetry. This is symmetry. If you can see carbon 13 NMR, carbon 13 NMR. So again, you will see the symmetry. This and this are same. This and this are same. Again, you will see the two peaks. Again, you can see the two peaks. This is of 2 marks. Then they are saying the proton NMR spectrum of CHCO2H in D2O is obtained. D2O is the isotope of hydrogen. It's the heavier isotope of hydrogen, which is called deuterium, whose mass is 2. You know, whose mass is 2. Proton number is the same, but the mass number is different. So the mass of deuterium is 2. So describe and explain the difference observed between this spectrum and the proton NMR spectrum of HCO2H in B part 2. So what do you think, like if you are have dissolved this substance in D2O, so like what would be the difference between the NMR spectrum before and after dissolving? Yes, like is there any difference in the number of peaks? Would the number of peaks be different, or it would remain the same? Yes, हाँ जी. क्या कहते हो बासिल? OH में सॉरी D2O में अगर मैंने इसे डाल दिया तो क्या डिफरेंस आएगा इन NMR स्पेक्ट्रम? या what like you are thinking that it would remain the same?
सर अभी तक एनएमआर पढ़ा नहीं है।
अरे माशाल्लाह माशाल्लाह, ये भी अच्छी बात है बेटा। चलो मैं बता देता हूँ आपको। NMR में D2O, after dissolving in D2O, your your labile hydrogen would be replaced. Like your reactive hydrogen would be replaced. Your reactive hydrogen would be replaced. Your reactive hydrogen, like reactive bole to this hydrogen would be replaced by this. It would become OD. It would become OD. then HD. It would become OD. Like rather than OH, I can write, rather than OH, I can write this is OD. So this peak will disappear. This peak will disappear. Okay. So what am I supposed to write over there? What am I supposed to write? Okay. इसमें I would write K OH peak, OH peak disappears, OH peak disappears, OH peak disappears. Why? Why? Because H H is exchanged by deuterium. This is the most difficult question in the whole organic. In the whole organic. Now, think about it. Think about it. And then tell me what should be D, what should be H. Draw the structures of G and H. Suggest reagents and conditions of each of his step 1 and 4. Of each of his step 1 and 4 basically.
सर स्टेप 1 एंड स्टेप 3 में ब्रोमीन हटा है और अल्कोहल बनेगा शायद.
Okay.
एक्वस NOH.
Aqueous NaOH, aqueous NaOH. Now you can see कि इसमें क्या हो रहा है. Count the number of carbons in your reactant, in your final product. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oh भाई, इतने सारे कार्बन, इतने सारे कार्बन. 4 to 6. 4 to 6. 1, 2, 3, 4. This is the same. This is the same. So this, you have to think about that after looking at the reactant and the product. Reactant and the product. First of all, अच्छा ये बात तो पक्की है ना कि cyanide, बोले तो nitrile is used to increase the number of carbon atoms, and I'm supposed to write down the note over here कि nitrile, that is CN, is used to increase carbons. According to me, the 2-cyanide group is attached. According to me, the 2-cyanide group is attached. So it would become 6 carbon atoms. And then you can reduce this CN into this. It's a very important concept. You can reduce nitrile into CH2NH2. You can reduce nitrile into CH2 or NH2. देखो ये आइडिया है. दिस इज एन आइडिया कि ब्रोमीन से NH2 आया और नंबर ऑफ कार्बन भी इंक्रीज हो गए. बट हाउ इज दैट पॉसिबल? ये डायरेक्ट नहीं होगा. I cannot say that bromine is replaced by cyanide. I cannot say that bromine is replaced by like bromine is the halogen. Bromine is the halogen. So it's a nucleophile. It's a nucleophile, and cyanide is also a nucleophile. So there would be a nucleophilic substitution reaction. So CH2, then CH2, then CH2, then CN, or then CN. मैंने क्या किया? I have substituted the bromine with the CN. And the next step, मैं क्या करूंगा? इसको मैं reduce कर दूंगा. How? I can add hydrogen and nickel. That is a reducing agent. I can add hydrogen or nickel. That is a reducing agent. Or you can also use another reducing agent, that is LiAlH4. That is LiAlH4. Lithium, aluminium hydride. Lithium, aluminium hydride. You can also reduce in this way. So अब इसको सोचना है, what is this? To get an idea, what is this? This is carboxylic acid. This should be alcohol. This should be alcohol. तो मैंने क्या किया? CH2, 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 then OH. Then further जब मैं इसको oxidize करूंगा, I would be getting carboxylic acid. So you can do these questions in this way. You have to look at reactant and then you have to look at the product side और इस तरह से आपको आसानी से पता लग जाएगा. So step number one is yes, what can I write? What should be the reagent and conditions if you are going to substitute this bromine by OH? If you are going to substitute bromine by OH, yes, what reagent and conditions I am supposed to add in this? Hanji, any idea?
So in step
In step one,
so NOH, aqueous,
NaOH, what? Aqueous or ethanol? Aqueous?
aqueous,
Exactly. So it's NaOH and heat. Step two. Step two.
HCN in KCN.
Step two, भाई. Step two, यार. Step
Oh
two,
sorry,
भाई.
step 2. सर ऑक्सीडेशन हो रही है इसकी तो
Oxidizing agent कौन सा use करूं?
KMnO4
KMnO4, like acidified MnO4 minus slash H plus, and heat. And what should be step three?
HCN
Okay, HCN,
या SCN
Cn minus, like, or heat. Step four.
NH3 ammonia
Step four. Step four. Cn2, CH2, NH2. Addition of hydrogen.
reduction HCl.
Reducing agent.
Oh sorry,
You can say LiLH4, lithium aluminium hydride. लिथियम एल्यूमिनियम हाइड्राइड. चलो जी, ये देखना जरा, ये ट्राई करो, देन आई एम गोइंग टू टेल यू. Polyamide L can be synthesized to form from dicarboxylic acid and diamine. Draw the repeat unit. Draw the repeat unit of the polymer form. In the box, any functional groups should be shown displayed. Should be shown displayed. So let me first solve the dicarboxylic acid. That is this. This is -2. This is removed. Okay. ये remove हो गया. Finally, I got this. कार्बोक्सिलिक एसिड अपना OH रिमूव करता है और NH2 अपना H रिमूव करता है. I am going to copy this as it is, but this. this. Okay,
सर मैंने भेज दिया आपको.
गुड हो गया. ऐसे किया है.
Yes.
Okay, so this is your repeat unit. This is your repeat unit. चलें जी. See this. It's a nice question. M and N. Easy, 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 easy. You have to synthesize this. You have this. सोचो 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 फिर मैं बताता हूँ.
सर पहले ऑक्सीडेशन होगी.
पहले ऑक्सीडेशन होगी. क्या बनेगा? क्या बनेगा?
कार्बोक्सिलिक एसिड उस पे चेन पे आके लगेगा.
पहले ऑक्सीडेशन होगी और ये बनेगा आपका कार्बोक्सिलिक एसिड बनेगा. कार्बोक्सिलिक एसिड बनेगा. अच्छा जी. ओके, यानी कि ये बनेगा. राइट.
जी सर.
And this is electron donating group या electron withdrawing group? You will say this is electron
विथड्रॉइंग.
withdrawing group. Exactly.
3 5.
So, हाँ, तो जब you are going to do nitration for that, so NO2 group would be added over there. It's electron withdrawing group. It's 3 and 5 director. It's 3 and 5 director. So it would shift, it would direct the coming group to the third position or a fifth position. And then when you are going to reduce this into this, I told you Sn plus HCl. I told you in a theory that whenever you are going to reduce this NO2 into NH2, so you are supposed to add Sn plus HCl, tin plus hydrochloric acid concentrated, tin plus hydrochloric acid concentrated. So yes, what should be step number 1? Reagent.
सर ऑक्सीडेशन बाय KMnO4.
Good हो गया. Hot KMnO4.